Hello everyone, let's talk about prompt engineering. What is it? Art or science or maybe your next job title? I'm Maxim Salnikov. I'm based in Oslo, Norway, where I work in Microsoft, where I help developers to succeed with our cloud technologies, tools for developers, and everything related to AI. I personally a developer myself, and I build applications since late 90s of last century, and I'm a big fan of the developer communities. In Oslo, where I'm based, I founded a couple of conferences and run few meetups. My favorite topics to present about are web development, all kinds of cloud development, and of course, everything related to generative AI, including prompt engineering. I found multiple estimations on the number of people who use generative AI on our planet, and the most conservative ones say that it's well over 1 billion people. That's a number, right? What do these people use generative AI for us to start the discussion? I identified 3 large application areas. First of all, everything related to productivity. Your personal productivity, your business productivity, everything related to usage of generative AI in education and science and many other areas where we can really get super powered by Gen AI. Next, creativity. After all, it's called generative AI, right? So it can generate for us many very interesting things, so we can really feel ourselves super creative. But there should be someone who is building these applications for us, someone who is actually constructing these UIs that we can use both for productivity and creativity. And yeah, here I'm talking about people who are actually building these AI-infused or intelligent applications. And I'll do my best to make this particular session the most useful for exactly this category of people. But at the same time, I'm sure that even if you don't have any intention to build your application, you can still get lots of useful information from this session because it contains some general recommendations, some general practices for your improved prompting. And after this session, when you open any kind of generative AI powered service like ChatGPT or similar, you will know better how to communicate. What is common thing in all these scenarios? Let's look how we, for example, ask Midjourney to create a new image for us, or how we start conversation with Microsoft 365 Word on creating some very smart and solid template for our document. Or let's look at how we communicate with GitHub Copilot for improving our code. Not even saying about ChatGPT as a service itself, where we literally chat with this tool. Of course, one common thing is the way we interact and the fact that it all starts with the prompt, with some text that we write. And even though model landscape is emerging and there is next amazing model is released while I speak, while you watch this session, and there are already multiple models available, and it's becoming more and more complex. There are large language models, there is new generation of small language models, also multi-modality is really available now. Even though there are different kinds and types of models, some of them are general, some of them specialized, still we all go back to prompts. This is why I consider prompt engineering as a separate discipline, or at least as an essential skill of many people, not only developers, but many technical people, many people on business positions. And what is this after all? This is a process of designing prompts, of tuning these prompts and further optimization, while we keep satisfaction level on the results that we get back from the large language models. And of course, it's also important to follow cost efficiency, because in many cases, we talk about some paid services, when we talk specifically about like high-end large language models. Let's look closer at the prompt components, or if you wish, we can call it prompt anatomy. In many cases, at least when we are the users who chat with ChatGPT, we don't really think too much about how we structure our prompt. We just communicate, and as long as we are happy with the results, we don't want to dive deeper into all these nitty-gritty details. That's fine, but when you build your AI-infused application, it's really good idea for you to know how that works from inside. And again, the same ideas and techniques are still applicable to your like day-to-day conversations with any generative AI-powered service. So yeah, let me introduce how that works. In many cases, we have very clear and concise and straightforward instruction, what we want to get from this particular call to our generative AI service, or more technical precise, to large language model exposed by one of these services. And yeah, let me illustrate it by this example what's on the screen. Let's imagine that we are building applications for marketing automation that gives us nice, at least drafts, maybe ready-to-go emails that share details on some new products that we either produce or sell. Or it's not obligatory as in role of developers. You can use the same ideas and techniques when you just use ready products with some prompts available. Instruction, of course, we have to also provide some primary data about this product itself. Also, we can provide some context, or we can call it secondary data, about tone we expect. In this particular situation, we want to be friendly and exciting, but for different scenarios, there could be different ways of exact narrative that we expect from the model. Also, we set the format, we define the format we want to get back. And in this particular situation, it's definitely something that is in the middle of overall developer chain of this product, because you see that we expect not just text, but JSON. Definitely this will be somehow processed by the next steps of our, for example, backend. So we say that we want to get back not just subject and body, but JSON object with these fields. Also, we provide an example, and in this particular situation, it plays at least two roles. First of all, yeah, it demonstrates the model that the kind of text, maybe length of the text, and again, tone and all structure might be good fit for us. And also we double down on the format. So this is why we put example exactly in the format that we described on the line above. Why do we need this duplication? Stay tuned, I'll explain why that might be useful. So this is how we, human or developers, look at the prompt. And this is how large language model, or LLM, understands the same prompt on its end. And that it's split into tokens. And actually, tokenization is the first procedure that happens when you send prompt to LLM. So a large language model understands your prompt in form of tokens, and when time has come to generate answer for you, it also generates this recursively, token by token. On this example, that many words are equal to one token, right? One word equals one token, but of course the real situation is much more complex, right? So you see that some words take multiple tokens, and exact implementation of how that split is up to implementation of large language model or its tokenizer. There is no any kind of strict rule how many words equals to how many tokens, or how many characters equals to how many tokens. We can very approximately say that at least for this generation of LLMs and for English text, 100 tokens approximately equal to 75 words. So that means like one token is maybe around 4 characters in English text. For different languages, the ratio is completely different. You might ask me, why do we ever need to have this knowledge about tokens? Because definitely when we are in user role, this is hidden completely under the hood for us. We communicate with sentences in, sentences back. When we are in developer role, also, this is not that visible at the beginning of when you start building your AI application, but very soon as a developer, you will understand super important meaning of tokenization. And this is why, because number of tokens in your input and expected output. First of all, the cost of this particular call, if we talk about some hosted LLMs hosted by some vendors, and also there is technical limitation on number of tokens you can send and receive back. On this slide, there is some screenshot from pricing for Azure OpenAI services, for GPT, for O model and O1 preview model, and for legacy purposes, I also listed price for GPT-4. And that we are in good situation as developers because prices are going down. And first of all, that it's priced by 1 million tokens. So every single token for a few number of calls, maybe this is not something really crucial. The price becomes really different when we talk about some scale usage, but still very important to keep eye on it. And that in GPT-4, it started from $60 per million, and suddenly GPT-4o, that is more capable, more performant model, it's many times cheaper. And this is general trend. There is newer and newer technologies from side of providers of LLM services. And so it's very good, especially, for example, startups. They have to recalculate their economy and recalculate in a positive way. And next column I want to emphasize on this screenshot is context. And this is exactly number of tokens we can send in one particular request. So we see it's not number of characters or number of words or bytes or whatever. No, it's calculated in tokens. This is why it's very important to understand, at least roughly estimate number of tokens in your prompt. As you see, modern models are quite capable, and we talk about 100,000+ of the tokens. So we are not talking about every single word or white space, or not even about sentences, not even about paragraphs. Maybe you can currently send pages of text as a prompt for these models. And again, trend is work good for us. Models are capable to accept more and more tokens, but still there is a limitation, right? So you cannot send maybe a full book, at least currently, at least at this moment. So this is why, again, tokenization concept is extremely important, and we'll have few more slides on this topic. And of course, different providers of these LLM services provide different ways for you to save on this usage, all kinds of caching, all kinds of batch calculations when you don't need output here now, but you can wait a bit and then price for this call will be cheaper than regular. All kinds of some dedicated capacities. That really depends vendor from vendor. And you also noticed that model selection makes real difference. First of all, on capabilities, on quality of the output, and second, on the price. And I offer you to use this simple strategy on model selection. First of all, try with the most capable, the most performant, and in many cases also the most expensive model on the market. Maybe you can try different providers. Identify your best prompt that gives you the best possible results. Then you can try to downgrade to the next cheapest one, the next cheapest model. In some cases, you might need to fine-tune the prompt slightly, but check the results. If result or completion in technical terms, when we talk about prompt engineering, is the same or better, maybe you can do next step in this downgrade and try even cheaper model. Maybe, again, the results will be the same or even better. Sometimes that's also possible, and it will give you a chance to save some dollars. If no, then you just go up to the previous step where you downgraded from. It's a simple and efficient model selection strategy. Also, you can use multiple models, and in many cases, if we talk about not hello world AI infused application, this is not just one call to the LLM. It's a chain of the calls, maybe to multiple models, maybe to even to multiple providers, maybe mix between some hosted model hosted by external vendor, model hosted by yourself, and maybe even a model that is running straight on your device or on your customer device. So that really depends on business scenario. So if you have a chance to use multiple models in this particular feature of your AI-infused application, you can follow simple rule. For, let's say, complex tasks like generation, you can use expensive ones. This is where they really shine, and yeah, every new generation of the model provides better and better results in generation. While summarization, classification, categorization, this is, again, nowadays not that complex tasks anymore, at least for a large language model, and the cheap ones do them pretty good. Another strategy is chaining. For example, you want to send to a large, expensive model some large amount of text. This is how your prompt works, right? But you can leverage cheaper and maybe like very fast one, maybe your own fine-tuned model to summarize this large amount of text you are going to send to expensive one. Also might work good for you with minimal performance decrease. You will save some budget. Let's go back to token conversation. So I hope that I convinced you that keep an eye on number of tokens you send is crucial for economy of your application. Not only for economy, but also you remember that there is just technical limitation of a number of tokens you send. And after all, the shorter prompt, normally the faster you get completion. So it's like multiple reasons why you want to minimize your prompts. And how to do this exactly? First of all, very simple rule. Have a closer look at white spaces in your prompts. This is something that we can easily overlook because this is not something that is very visible, right? A couple of extra white spaces, we can just, okay, ignore this. But in reality, some large language models treat every single white space as one extra token. Not a big deal if we talk about one-shot request, but if we talk about, I don't know, hundreds, thousands, millions of requests, that might bring some difference to your final bill at the end of the month. Next, for different data formats, try different ways to like implement this data. What I mean exactly can be easily illustrated by example of how we supply date in our prompts. I'm technical mind, and my first impression was, okay, the shorter string with the date, the better chance that it will take fewer tokens. In reality, not at all. So you see on the bottom line, short format of the date takes 6 tokens, while on the top line, it only 3 tokens. So sometimes it's counterintuitive. Again, this is example for one particular large language model. I don't even remember which one. Different models can do it differently. Experimentation is the only way to really identify what's your optimal format for this or that type of your data. If we talk about tabular data, this straightforward tabular format is pretty much space efficient and what's very important, understood by LLM. No need for you to always reproduce JSON-like format where you supply caption for every piece of the data. No, just provide some table headers separated by pipes or tabs, or you'll find your personal separator and then rows with the data. In vast majority of situations, LLM will understand what you mean. Also, language makes real difference. I already mentioned that English is the most straightforward way for prompt engineering because it's the most efficient while we talk about tokenization, at least again for the mainstream large language models. I suggest this because vast amount of data, all this Wikipedia, public books, etc., data that was used for LLM training was in English. It still understands other languages perfectly well, but if we talk about tokenization, the same, let's say, concept, same sentence in different language might take more tokens than the one in English. I'm not saying that you have to translate every single time, but again, experiment. I want to start introducing some tools. On next slides, you will see more and more very useful tools, frameworks, libraries that can simplify your life as a prompt engineer. The first one called LLM Lingua, and this is nothing but prompt compressor. It's created by my colleagues from Microsoft, and it's open source, so you can take this tool and host it locally or on your own server. And yeah, as the description says, it takes your prompt and compresses it. But it does it in a very smart way. Of course, try to do it ourselves, right? But we do not always understand which parts of our prompt are crucial for LLM to really understand what we mean and which parts we can skip. Who can help us? Of course, another large language model, right? And in this particular case, this is compact one, maybe we can call it a small language model. So this one is used to identify and remove non-essential insert tokens in your prompt. And with some playing, some fine-tuning, you can get up to 20 times compression with either zero or minimum performance loss. Because definitely, of course, some time is needed for this first step, LLM or SLM, to compress your prompt. But on the other hand, prompt will be shorter, and it might happen that you save some milliseconds just because of that. If we take prompt from our first example about email, about new headphones, and run it through this LLM Lingua, I did it without any fine-tuning, just as it. So it took literally a couple of minutes for me to set everything up locally on my machine. I immediately got 17% compression of this prompt. And you see, the prompt looks approximately the same, right? But definitely something is removed, but the devil is in the details. LLM Lingua knows exactly what is non-essential for other LLMs. So I really encourage you to try this tool. Now, some general recommendations about prompts. Be specific and clear. The more concrete your order, your request, your ask to the prompt, the better chance you get nice results. At the same time, be descriptive and, if possible, use examples. Again, you might need to educate LLM a bit on what you expect as a completion. Order of the components of your prompt matters. There is no any kind of strict rule or rules on that, only some recommendations, and it's on the next slide. Sometimes you need to double down. Sometimes you need to repeat either instruction or format or any other component of the prompt. Again, this is not a trick, absolutely. But if you are unhappy with the results you get back, try, experiment. And for the cases when we talk about classification and categorization, you better explain in your prompt explicitly. Like, if you don't know which category to put this text in, you better say, I don't know, rather than put it into the one or another bucket that you provided in the prompt. It will save you time on validation of the results. Based on this general recommendation, some a bit more technical ones, or more concrete ones, we can say like this. Back to order matters. Normally, for your optimal prompt, you start with clear instructions. In some cases, you might want to repeat instructions at the end. Again, this is not a requirement, you just need to experiment. Don't be shy to provide very clear syntax in your prompt. Just provide some separators between different sections. You can even call these sections. The better chance you explain LLM what is what in your prompt, the better result you get back. Don't try to multitask. One prompt for one task. You better organize set of the calls, like chain the calls if you need to perform something complex. And also, many providers of the models and many models are capable to accept some extra parameters, not only prompt itself, but some parameters for steering output a bit. In case of GPT family, these two parameters called temperature and top probabilities, and they both affect how creative this model is, how deterministic you want your answers to be. Of course, model output are non-deterministic, right? But if you, for example, put temperature to 0 and top probabilities to 0, the better chance that you will get the same result for the same prompt. Otherwise, if you put everything to the maximum, it will be as creative as possible. Let me list a couple of techniques that is widely used in prompt engineering. And again, it might be very useful in your a career of prompt engineer or AI engineer or just a developer. And zero shot versus few shot prompts. By saying shot, we mean example here. And let's imagine that we are building some automation tool for insurance company for first line of support. And we gathered question from our customer via email automation or maybe a transcribed phone conversation. And we want to pass it to this or that department of our company, it either auto insurance or flood insurance. The prompt is pretty straightforward. We ask to categorize 1, 2, 3. And this prompt illustrates one of the techniques I mentioned, giving model an out. So if the question is not relevant, you better say it's not relevant. Just mark it as 3 in this particular case, rather than force push it to either auto or whole flood insurance. Again, we'll save some time on validation of the results. This prompt might work good. If it still fails in some situations, you can educate this a bit. Use the same prompt, but somewhere in the middle, inject a couple of examples. Maybe examples that use specific words from this specific field. Maybe if like from your specific geo area, or I don't know, something that is from a real use cases. And where a model, for example, failed last time, you can supply this as an example and you'll get definitely better results. Also, you have to find a balance. Your prompt becomes a bit longer, right? That means a bit more expensive, maybe slightly longer time to process completion, but content or like result is the king after all. We want perfect output. Another super powerful technique called chain of. This particular example is solving math problem. First of all, maybe I'd say that LLMs are not perfect mathematicians at all, and normally you don't use this for solving any kind of math problems, but I really want to illustrate this technique by it's simpler or whole to illustrate it by this math story. So just imagine that we want to ask for an answer on some simple math operation. So in the white prompt, in the light blue, there is output or completion, more technical term. Result is here and it's wrong. So 8 million liters per year is completely incorrect. I don't want to dive too deep why that happens. In very simple words, LLMs are trying to find the lowest hanging fruit in all these kind of calculations. Of course, it's not real calculations. But I want to explain you how to fix this and possibly many other situations. Not limited to any kind of math or like science things. If we add one simple sentence, let's think step by step and explain calculation step by step. As a result, our completion will be a bit longer, that's fine, but the most important thing is answer is correct. And also, by the way, this is not exact wording you have to use all the time, this let's think step by step. No, you can experiment with longer, shorter description, something like customized description, but you have to force model to literally think step by step or provide reasoning behind every step, and the results will be better. You will clearly see this. Another technique is not exactly about prompting itself, but how we construct overall communication with LLMs. And in many cases, we need to send multiple calls to complete one particular task. I already told you that not good idea to multitask one prompt for one operation, but you can easily organize prompt chaining by orchestrating some backend tooling. And you can use, again, multiple models for multiple tasks, hosted model from one provider, another provider, your own model, local model, fine-tuned model, general model, you decide, right, what works best for yourself. And the whole idea is very simple. You can use output of previous call to the model or parts of this output as a part of the input for your next call. So this way you achieve a very good situation when you literally get what you want with minimal efforts. And this is hallucination. Hallucination in context of our interactions with the large language models. And this is something that is really annoying in all kinds of AI engineering, in all kinds of prompt engineering, all kinds of building AI-infused applications. So this is, again, outcome of how LLMs were designed, invented, and how they work. In summary, they are very good in making up facts and making this in a very trusty way. So it's very complex sometimes to identify what is correct in this output and what is wrong if we talk about some facts we requested. Fortunately, there are multiple ways for, if not removing completely, but reducing hallucination, mitigating its consequences. For example, you can explain model not only what you want, but also what you don't want to receive back from this. So you can limit number of use cases. Also, this is a recommendation that I already introduced. Give model an out. If you are not sure, say I don't know. This simple statement could be a part of the prompt. As well as this one. Sometimes it's super naive technique, right? But sometimes that works. Don't make up facts as a part of your prompt. If there's a chance for you to organize multiple short conversation with your LLM, like chat-like, maybe you can ask every time, are you sure that you have all information to answer this question? If not, you better request some extra ones. Step-by-step reasoning and asking model to explain along with the answer, basically this is a chain of thoughts technique, also helps. But all these points what on the picture are nothing compared to this. You can dynamically find and inject relevant context information straight into your prompt. And you can say, use only this information for answer. I mean, forget all your knowledge from Wikipedia and the public books, discard this. We only need you to use this data and it's straight in the prompt. I can illustrate this by example of us in the role of developers who build internal application for, say, our employees to investigate what's possible in medical insurance coverage for them. And let's imagine that we gathered a question from employee via chatbot or again via some automated email engine. Does my health plan cover annual eye exams? And at the top of the prompt that we explain all the prerequisites. We are intelligent assistant and you can answer questions about healthcare and use only sources below for the answer. And we also directly inject into this prompt these three sources that are relevant for answering this question. Sounds very simple, right? But of course, we have to, completion in that case will be nice, correct. But how do we exactly identify these sources? How do we find these sources, these few sentences in, for example, dozens of PDFs or documents or somewhere in database? How we identify these sources, how we shorten these sources, how we rank them after all to provide top 3 or 5 or 10, depending on your use case items. And to this question is retrieval augmented generation pattern or RAG. As name says, it's about retrieve these sources, these data sources, augment them and augment your prompt, and after all, generate completion. Generate completion is trivial. This is about sending your final prompt to LLM. Augment is even simpler. This is just a string operation. This is literally inserting sources of information into your prompt, like we've seen on this previous example. Retrieve is the real magic. How, based on this particular question or on question plus previous conversation, we really identify data we need from, again, back to use case with dozens of PDFs with all this insurance information. And of course, here we can leverage one more large language model. This one, say one that we use for the final call, or most likely in vast majority of situations, this will be completely different one, specialized. And also you might want to vectorize your request, and thus you have to send this request to a vectorized database. Unfortunately, it's all out of our today's scope. This could be your homework to learn more about retrieve component of RAG. And in the real world, it's even more complex because it could be multiple sources of this information, right? So before constructing your final prompt that contains everything, you might want to send request to your internal database, to some external API, and who knows where else. So maybe you might want to have some orchestration support. Surprise, surprise, in real world, it's even more complex than just this orchestration. And if we talk not about this particular call to or chain of calls to LLM, but also about full life cycle of our AI-infused application, or like a generative AI part of this, we want to get some tools, some frameworks for ideation, for building, for making everything real, how we deploy, how we monitor. It's, let's say, very specialized part of DevOps, but specifically for your LLM interactions. We can call this LLM Ops. So let me introduce more tools that can help us both with this orchestration of our calls and the operationalization of all flow. First couple of tools I want to mention is LangChain and Semantic Kernel. And these are amazing orchestrators of everything you need to interact with any kind of LLM. So these two libraries or frameworks, you name it, are very similar. They support slightly different set of programming language, slightly different set of platforms, but in a nutshell, they are helping you to get very nice abstraction over all your interactions with LLMs. So you don't need to write all these calls, all this ping pong from scratch. Also, there are many more very interesting features included in both of the frameworks. So when you start your new AI-infused application, don't ever start like your low-level communication with LLM from scratch. Find your perfect level of abstraction in these two or any other frameworks. And for overall orchestration or operationalization of your LLM application, I recommend to have a look at Conf42, another open source tool, and this one also created by my colleagues from Microsoft, that in code-first way can help you, again, to keep full control over full cycle of your LLM development, starting from experimentation up to monitoring. Conf42 UI could look like this. This particular short video is from the hosted version. There is one on Azure, but you can get the same UI straight in your VS Code IDE via respective extension called Conf42. Basically, it reproduces your interaction with LLMs as a graph where some nodes are pieces of Python code, some nodes are calling of LLMs, some nodes represent prompts with where you can iterate through multiple variants, for example, to identify what is the best. And after all, you can host everything on the cloud of your choice. There are many learning resources available about prompt engineering, and I hope that you will get PDF of this session with all active links. What is the future of prompt engineering? I have set up the questions. I will not give you answers on. I encourage you yourself find the answer. For example, will it be separate job title or just essential skill? Will it become simpler with tools like LangChain, Semantic Kernel, Conf42, or they become more complex because there is multimodality, you have to closely work with vectors if you talk about RAG, etc. Thus, will it be democratized and pretty much everyone who ever sent a request to ChatGPT will call themselves prompt engineer, thus there will be title inflation, or it will be more gated discipline? And who will benefit the most people who understand how our language constructed, linguists, or people who understand how code works, technologists, or maybe people who know everything about this particular domain where this application comes from and able to formulate the problem. And do we survive competition with LLM-based prompt engineers? Because LLMs are also perfect in creating prompts. I invite you all to the Prompt Engineering Conference I organize in November, and this will be second edition. First edition was last year, super popular. And if you watch this session before November 20, just go and register your ticket. If you watch this after, still go to the same URL. You will find all sessions recorded straight there. And it's online, it's free, open for everyone. Thank you very much for watching this session, and my last prompt for everyone. Let's stay in touch. This is my LinkedIn profile. Find me and just scan this QR code or find Maxim Salnikov Microsoft on LinkedIn, and it's my great pleasure to stay connected with you. Ask me about prompt engineering, AI engineering, any questions, or any questions about web development and cloud in general. Thank you very much.